In this video, we're going to look at one of the most common algebra mistakes, one that essay students make almost every day, and it concerns algebraic fractions, which are in a form something like this. So if you've got a fraction with a variable, like an x, in both the numerator and the denominator, then it's very tempting, especially for students who are new to algebraic fractions, to say, well, hey, there's an x in the top and the bottom of the fraction, surely then they just sort of cancel each other out. Now that is not correct, but following that logic, that would then say that if they cancel, we're left with a 4, so the answer will equal 4. And a lot of students will write that answer, especially if they're new to this, and even if they're not new. So I see experienced students still doing the same thing, but this is wrong for several reasons. First of all, a clue would be that the answer here, 4, is suggesting that this always comes out to be 4, which looks a little strange given that these have got variables. So that doesn't intuitively seem correct. If we then actually take a value for x and substitute it into the fraction, so if we let x be 2, for example, it should be, according to our logic here, that the answer is going to be 4, always going to be 4. So if we put a 2 in here in the numerator, we get 2 plus 4 divided by a 2 in the denominator. So 2 plus 4 is 6 divided by 2, which is 3. So these are not consistent, so something has gone wrong there. And the thing that went wrong was our initial approach, was the way that we just cancel these terms. So you've got to be really, really careful with just assuming you can cancel in an algebraic fraction. Let's look at what we should have done. Well, x plus 4 divided by x, what does that really mean? It means that the x on the denominator, which remember just means divide, a fraction is another way to write divide, that x is dividing both the x and the 4. But in our cancelling, we're sort of just thinking of the x as dividing the x and forgetting that this x is also dividing the 4 on the numerator. So if we think about this correctly, this is really saying x divided by x, which we can literally write down, plus 4 divided by x. Now x divided by x, or any number divided by itself, is just 1. So that would simplify, let me put it here, to just 1 plus 4 over x. Now if we take a numerical value like 2 and substitute it in and see what happens. So we know that the correct answer when we substitute in 2 should be this number here, 3. Let's see if we get that answer when we process it this way. So that would be 1 plus 4 divided by 2, which is 1 plus 2, which is 3. So that does give us a correct answer using the correct method. So just remember that any fraction, whether it's numerical or algebraic, is just another way of writing divide. And remember that whatever is on the denominator is dividing everything that is in the numerator. However, I can understand why it's confusing for students, because there are scenarios where you can just cancel. For example, this slight modification from this example is such that we are just allowed to cancel off the two x terms. Now, why is that? And why is it different? It's different because here we've only got one term on the numerator. Now, it might look like you've got two terms or even several terms, but this x is multiplying to the bracket. As soon as it becomes a multiplication of the bracket, then that effectively makes it into one term. This is just like sort of one term. They're gathered together in this particular form. Because there's only one term, if you divide the top and the bottom of this fraction by x, remembering that x can be any number, then that one would cancel and that one would cancel, so you have cancelled the x's from every term. Whereas over here, just cancelling those x's was forgetting about the 4. But by cancelling that x on the top, you're already cancelling it because it's part of the bracket, so you don't need to worry about those terms that are within the bracket. So you can see the difference between that and that is fairly subtle, and for a new student or even a reasonably experienced student, it's not easy to distinguish between the two. So I would never criticize a student for making this mistake initially, because it's really, really common and it is a little confusing, but you've just got to learn from the mistake and basically just be really cautious when you go instinctively to cancel in an algebraic fraction. If you look at this scenario here, again, it's the same fraction just flipped. A lot of students will just say, hey, there's an x in the top, an x in the bottom, I'm just going to go ahead and cancel, just like this, and then they'll say, okay, that's going to leave me maybe just 4, or a more common response here would be that, hey, I can kind of see that the 4 is in the bottom part of the fraction, so maybe the answer is 1 over 4. But again, that's not correct. The answer is not 1 over 4, and you could prove that just by substituting in some value for x and seeing that the answer isn't going to come out to be 1 over 4. So in fact, in this scenario, there's really nothing you can do. You can't even distribute in the same way we did here. We made this one fraction into 2. You can't even do that. Again, just be aware that this x in the top is being divided by all of x plus 4, not just the x. And because it's not just being divided by the x, that's why you cannot cancel. So the takeaway from this video is to be super careful when you instinctively just want to cancel in an algebraic fraction. Just think about whether the scenario does actually allow you to do that, or if you've got to be more cautious. But really, you just need to gain enough experience to know in which scenarios you can cancel and in which scenarios you cannot. In this video, we're going to look at a common algebra mistake, one that I regularly see students make, and even experienced students, for example, a calculus student, might still make this error in their working. So we're talking here about a bracket being squared. So if you're brand new to this and you see a bracket being squared for the first time, then instinctively you might think that you just square everything inside the bracket, and that kind of makes sense, right? So you would take the x and you would square it, and then you would add to that the 4 being squared, and that's what students will do the first time they ever see this scenario, and then they might even go ahead and simplify that to x squared plus 4 squared, which is 16. But that's not correct, because when you square anything, whether it's a bracket or a number or an algebraic term, you're multiplying the thing to itself. So if you want to process x plus 4 all squared, so in other words x plus 4 with a squared outside the bracket, then you've got to keep in mind that that really is just a shorthand way of writing x plus 4 multiplied to x plus 4. And when you multiply two brackets together, you should get 4 terms. So we can draw little guidelines on to remind us how to multiply two brackets together. And basically it's everything in the first bracket multiplying to everything in the second. And if we go ahead and process that, we'll get x times x to give us an x squared. X times 4 gives us a 4x, we get a second 4x, and then 4 times 4 gives us the number term on the end, which is 16. We can simplify this by combining the two x terms, and we get x squared plus 8x plus 16, which is not quite the same as what we got up here. So if you're brand new to algebra and you've never seen a bracket being squared before, then absolutely understandably you're probably going to do this. It would be quite unusual and very smart of you if you realize to do this. But even experienced students will make this mistake, especially under exam conditions when they're feeling a little stress, because they don't write the bracket down twice. So my big recommendation here would be that if you ever see a bracket with a squared on it, even if you've done these a bunch of times before, just take a line of work in to write the bracket down twice. I still sometimes do that, just to give myself a little bit of headspace to think about what the answer is going to be, and then you can go ahead and process the terms like we did here and get to the correct final answer. So that's maybe something to keep in mind, both as an inexperienced student who's new to algebra and an experienced student. And similarly, I will see scenarios where the bracket is not being necessarily squared, but even for new algebra students where you've got two distinct brackets, and they'll do a similar thing. They'll kind of know they've got to start multiplying things together, so they'll multiply the x's together, they'll multiply the numbers together, so they'll be getting, in this case, x squared minus 10, but they'll forget about the x terms. And it's a slightly different scenario from over here, but kind of similar misinterpretation of what they need to do. So again, here we should have generated 4 terms by multiplying all these together, so it should have come out to be x squared, and then there are 2 x terms in the middle, so minus 2x, positive 5x, and then the minus 10, and then just tidying this up again with the 2 middle terms to get a plus 3x at minus 10. So similar scenario to this one, not quite the same. The 2 brackets are already there, but still again very easy to forget about these middle x terms. Just one third scenario to look at and to be mindful of, just to complete the whole sort of picture here, is when you've got 2 similar brackets, but one has got a positive number and one's got the same number but a negative. So if we go ahead and process this one correctly, so multiplying all the terms in the first bracket, all the terms in the second bracket, we're going to get an x squared, we're going to get a minus 2x, we're going to get a plus 2x, and then we're going to get a minus 4. But in this case, the x terms do cancel because we've got a negative 2x plus 2x, which is 0. So we do just end up with x squared minus 4. So the reason why I'm showing you that example is because there are scenarios when you are going to get something that looks like that, sort of, and it is correct. But the reason why this one is different, this is called a difference of two squares. And when you factorize a difference of two squares into two brackets, it does look like this. In other words, whatever number you've got here, the square root of that number goes here and here, with one positive and one negative. Doesn't matter which way the positive and negative go. So a few different scenarios there, but the main takeaway is that if you're particularly when you're seeing a bracket with a square on it, write the bracket out twice and then process it fully rather than trying to skip straight to the final answer. So it's really, really easy to make all these little algebra slips, especially under exam conditions. So just take a moment to be mindful of what you're actually doing, and that's going to help you to avoid mistakes. In this video, we're going to look at a common mistake students make when trying to solve quadratic equations. And I'm going to demonstrate this by looking at these two examples. So remember, a quadratic equation is one which contains an x squared term as the highest power, and these need to be solved by factorising. Well, there's a few methods for solving them, but the algebraic method is factorising. So students will often remember that. They'll see an equation like this and they'll say, hey, that's an x squared equation, that's a quadratic. They might not be able to name it, but they'll know that it's a type of equation that involves some kind of factorising method. So they'll say, hey, wait a minute, I know what to do here. I can pull out a common factor of x. So they'll go x and then open a bracket and then they'll go x plus 2, usually getting that factorising correct. And then they kind of also remember that these generally have two solutions and there's something to do with splitting it off into two equations. And they'll go, right, I've kind of got that now because I can go x equals 8 and then write that down as a first solution. And then I've got this x plus 2 equals 8. And that's going to give me my second solution, and I'll go ahead and solve this to get x equals 6. And these are the two solutions. Now, we can test whether or not those are the correct solutions, which they're not, by plugging them back into the original equation, because the solutions to any equation should satisfy the original equation. So if we take, for example, the 8 and put it back into the original, so we get 8 squared plus 2 times 8, then that should all total up to be 8 if the equation is going to be satisfied. But 8 squared is 64, 2 times 8 is 16, so that comes out to be 80, which is nowhere near 8, so it didn't even come close to satisfying the equation. So where did we go wrong in this question? Well, we went wrong because quadratic equations have to be set equal to 0 before you factorise. So let's take a look at what we should have done. We should have started by subtracting 8 from both sides to make the equation x squared plus 2x minus 8 equals 0. In other words, making it into a quadratic expression, a trinomial in this case, equal to 0. From there, we then factorise into two brackets, not one bracket, although it is possible to factorise into one bracket in a quadratic equation, but not this particular one. And then a plus 4 and a minus 2, that would give us a minus 8 when we multiply those together. Positive 4 minus 2 gives us plus 2, so that's the correct factorisation. And it's those two brackets that we then separate into two mini equations to get x plus 4 equals 0, and to get x minus 2 equals 0, given solutions of x equals negative 4 and x equals positive 2. And it should be that if we plug those back into the original equation, the equation is satisfied. So if I take the 2, for example, and put it back into here, we're going to get 2 squared plus 2 times 2, and that should come out to be 8. 2 squared is 4. 2 times 2 is 4, so 4 plus 4 does give us 8, and that does satisfy the original equation. So I see students doing this all the time, and not only inexperienced students, but even calculus students who've been doing quadratic equations for years will make this mistake. And why do they make the mistake? It's because these are quadratic equations, but the other type of equation which is commonly solved is a linear equation. So something like this. If you've got the equation 2x plus 1 equals 11, that's a different type of equation altogether. That's a linear equation. It's just got an x to the power of 1 term. When you solve linear equations, though, we don't use this technique. There's no factorising, there's no equal to 0. In fact, the goal here is to separate the variables, the x's, from the numbers. So in this case, we would subtract 1 from both sides to get 2x equals 10, and then divide both sides by 2 to get a final solution of 5. But because students have generally done hundreds, if not thousands, of linear equations before they get to quadratic equations, they're used to getting the number on one side and the variables, the x's, on the other. That's why they set it up like this, and then they carry on and get these incorrect solutions. So the really important point is to note that linear equations and quadratic equations are separate types and they need separate methods for solution. And in fact, quadratic equations turn into linear equations at this point. So that's a really, really common mistake, and it's not only when the equation is written like this and students fail to take the 8 over to the other side. Even if it's already set up correctly, equal to 0, set up as a trinomial, students will still do the same thing because instinctively they see an equation and they think of this sort of setup rather than it being a quadratic, and they'll go like this: x squared minus 10x. Wait a minute, I've got an equation, I need to get the x's on one side, the numbers on the other, so they'll put the 21 on the other side, make it as minus 21, and then they'll carry on with the factorising like this, and then they've now fallen into the trap that we fell into here, and they're going to carry on and still get 2 solutions, but they're going to be incorrect solutions. What they should have done was just from this first line go straight to factorising, because the equation was already set equal to 0. This would factorise with a 3 and a 7 and 2 negatives, and these would eventually give solutions of x equals 3 for the first factor, and then for the x minus 7 factor, a solution of x equals 7. So like I say, it's not only new algebra students and inexperienced students that make this mistake, lots of students make it. Just be mindful that you're always working with a different type of equation. Ask yourself, is it a linear equation? Is it a polynomial equation? Is it a quadratic equation? Is it a trigonometric equation? They all need different methods of solution. So I hope that helps, and any questions or comments, please just leave them in the box below. In this video, we're going to look at one of the most common math errors, one that I see students make almost every day, and it concerns squaring negative numbers. So if I give a student, for example, the number minus 4 and ask them to square it, a lot of the time they will do this. They will write down minus 4 and square it like that. And intuitively that seems kind of right, because you take the number, you put a little 2 on it, and that means the number squared. And proceeding from there, they'll say, okay, well 4 squared is 16, so the answer has to be minus 16. But that, of course, is not correct, because when you square anything, you multiply the thing, the number, the algebraic term, whatever it is, to itself. That's what squaring really means. So if, for example, we write 5 squared equals 25, so we might just know that 5 squared is 25, but that's because in our brain we've already processed what 5 squared means, which is 5 times 5. So we've got like an intermediate line of work in here where the thing is being multiplied to itself. So taking that logic to the number minus 4, if we take minus 4 and want to square it, then that should be the number, the operation minus 4 times minus 4. But when we do minus 4 times minus 4, those are 2 negative numbers. In other words, a double negative, which makes a positive, so that's going to come out to be positive 16. So be really, really careful with that. Students make that mistake all of the time. Or another thing that they will commonly do is to write down minus 4 squared, but still present the final answer as positive 16, because they might remember that when you square a negative, you get a positive. But this is unlikely to get the marks either, because this is still, well, these two things are not equal. The answer to this should be minus 16, but the question was to square minus 4, which should be minus 4 all squared, and it should be written like this. Should be minus 4 in a bracket squared equals 16. So if you ever get a number, a negative number, and you've been asked to square it, it needs to go in a bracket, or you need to write the number down twice, or even both. So if you were asked to square, for example, minus 5, then you should write it as minus 5 in a bracket squared. You can then go straight to the answer 25, or you could put in an intermediate line of working, which would be minus 5 times minus 5. That's then a double negative, so the answer is going to be 25. But just remember that anytime you're squaring a negative, it should always come out to be a positive solution. There's very few scenarios where you're going to be processing something like this. It's usually going to be the negative number all squared, which will then turn into a positive. So just to highlight this point of when you square something, you multiply it to yourself, let's look at another slightly different but related error that students make. If you've got something like 3a all squared, a lot of students will write down the answer as 3a squared. They see the a, they see the thing being squared, and they think, well, an a squared is a squared. They forget though that 3a all squared, again, it's just really shorthand, like writing the squared is a shorthand for multiply that 3a to itself. So this really means 3a being multiplied to 3a, But in that scenario, we need to multiply the numbers together to get a 9 and then the a squared. Okay, so it's not a bad idea whenever you see anything squared, a number, a bracket, an algebraic term, to write the thing down twice, multiplied together, because that is what it actually means. Another really common scenario in which you see the issue with a negative being squared is when dealing with quadratic equations and using the discriminant. So if you're not familiar with quadratic equations, don't worry too much about this. This is just an example of one of the most common places that I see students failing with the negative being squared. So in quadratic equations, we've got this quantity called the discriminant, and it relates to the numbers, the coefficients of the x squared x term, and then the number term. So in this scenario, the a value would be 1, and the b value would be -2, and the c value would be 3. If you've got no idea what I'm talking about, if you've never seen these, then don't worry about it. This is just a specific example. But you can still follow along to see where the error comes in. So we need to work out this quantity here using our a, b, and c values. So we write down b squared minus 4ac, and quadratic equations are super common in like Algebra 1, Algebra 2, pre-calculus, even into calculus. So discriminant is all over the place. So quite often in the discriminant, the b term, which is the coefficient of the x term, will be a negative, and the formula has got that b term being squared. So students will go, okay, it's -2 squared like that, and then -4 times the a value, which is 1, and then the c value, which is 3. -4 squared is going to be, -2 squared is going to be -4, and then 4 times 1 is 4, times 3 is 12, -12, and then they get -16. Of course, that's not correct, because this here should have been in a bracket. What we should have done was make this -2 all squared -4 times 1 times 3. So -2 all squared then is +4, not -4. This comes out to still be -12, giving us a correct final answer of -8. So that's just one instance in which to watch out for squaring negative numbers. So I think the best takeaway maybe from this is, first of all, to know that a negative number always squares to a positive, but secondly, just to keep in mind that when you square anything, you're multiplying the thing to itself, and that's where the double negative leading to that positive final answer actually comes from. So just be careful with that, and I hope that is helpful.